All right, so we're going to go over our Chapter 3 test, which is the first step of is watching this Edpuzzle video so that you can earn back credit on your Chapter 3 test. So question number 1 is a graph that needs to meet the following criteria. A non-function, so it needs to fail the vertical line test, contains the coordinate 3, 4, has both domain and range restrictions, and it needs to be continuous data, which means that it connects from side to side. It's not individual coordinates. I think the easiest place to start is boxing in our domain and range. So our domain stretches from -5 to +7 on the x-axis. So I like to draw in vertical lines so that I make sure it's going from sideline to sideline. Our range goes down from -8 and all the way up to +5. So I'm going to draw horizontal lines. So that means this picture, this graph that I'm going to draw needs to fit inside of that box. It needs to be pictured inside. Next, I'm going to make sure that the coordinate 3, 4 is included in my graph as well. So it needs to connect, so I can't pick up my pencil at all. And I also need to make sure that it would fail my vertical line test. So I'm just going to go from the right-hand side, go through my coordinate, maybe loop back so I fail my vertical line test, and comes back down. Okay, so it's a non-function because I fail my vertical line test at a couple of different places. I go through the coordinate 3, 4. I go from side to side, left to right, so I meet the criteria of my domain. I go from top to bottom, so I meet my range. And then it is continuous because I don't have to pick up my pencil at all. Question number 2, create a graph that is a function, so x cannot repeat, has a slope of 1/2, and contains the coordinate -2, 6. So I think the hardest thing here is getting that slope to be 1/2. So remember, that's our change in y over change of x. So my change in y has to be an increase of 1. My change of x has to be an increase of 2. Since they're telling me I need to contain -2, 6, I'm just going to start with -2, 6. So I at least have that part of the criteria done. Then my change in y needs to be an increase of 1 every single time. My change in x needs to be an increase of 2. So I'm going to add -2 plus 2 plus 2 plus 2. And 6, I'm going to add 1, add 1, add 1. I know it's also a function because none of my x values repeat. List 3 different equations that are nonlinear. Explain why they're nonlinear. So remember, if a function is linear, the key here is that the x has an imaginary exponent of 1. When that changes, we don't have a linear function. So you could have had a ton of different examples. We could have said y equals x squared due to the square, which is going to make it into a parabola. So that is nonlinear. You could have put y is equal to the square root of x. Remember, the square root of x is taking x to the 1/2 power, which would not be an exponent of 1. You could have had a fraction, y equals 1/x. That is the same as saying x to the -1st power. So the key is that x cannot have an exponent of something other than 1. It could have even been absolute value because that's a change in direction, so that would be nonlinear as well. Function notation, we're looking at 3 different functions, f of x, g of x, and h of x, so we need to make sure that we are locating the correct function. So g of -2 is going to go into our pink function. So remember, if it's inside the parentheses, that's representative of the x value. So it's just saying that x is -2. So in place of x, I'm going to put in -2. So I have negative x, which is -2, plus 9, when I go to simplify, those double negatives do become a positive. So 2 plus 9 is 11. H of 14. So this time I am going into my green function. So instead of plugging in x, I'm going to plug in 14. 7 over 14 can be simplified down to 1/2. So h of 14 is 1/2. C and D are a little bit different because they are asking for x. They said find x if g of x is equal to 29. So I'm going to take my expression, negative x plus 9, and set it equal to 29 and solve. So I subtract 9 from both sides to get 20, divide out by -1, so x's value is -20. So that means g of -20 is equal to 29. The last one, we all missed this question. We're plugging in for f of x, our top equation. Once again, we're finding x. So we're going to set our expression equal to 65. I add 7 to both sides to get 72. Divide out by 2 to get 36. The opposite of squaring a number is taking the square root. The square root of 36 is 6, but remember, there's 2 different ways to get 36. If I plug 6 back in, of course it's going to work. 6 times 6 is 36. But if I plug -6 in as well, it works. -6 times -6 is positive 36. That exponent of 2 means you're going to have 2 different answers. Our 2 answers are -6 and positive 6. Question number 5 was reading the graph. So is this relation a function? Yes, because it passes our vertical line test everywhere we draw one. Is it linear? No, because there are different rates of change, different slopes. Is this relation discrete? No, because discrete data is just individual coordinates, not the connectiveness of the line. Find the value of f of 6. So I go to 6 on the x-axis and go up until I hit my line at 20. What is x if f of x is -20? So I go to -20 on my y-axis and over until I hit my graph at 1. The domain is how far left to how far right. So this is my furthest most point on the left and to my right. So that goes from 1 to 12. My range is how low to how high. So this is how low, this is how high. I go from -20 to 30. Graphing. Graphing the line y equals 7. We can rewrite that as y equals 0x plus 7, if that helps. We are emulating the formula y equals mx plus b. My slope is 0. My y-intercept is 7. So I start at 7. If my slope is 0, I don't rise any, but I run 1. Rise 0, run 1, rise 0, run 1, and I have a horizontal line at y equals 7. Remember, every single coordinate that I pick along this line, 4, 7, -5, 7, 0, 7, no matter what coordinate I choose, the y value will always be 7. Hence, y equals 7. X equals -6 is a big difference because instead of saying y equals a number, it says x equals a number. So instead of graphing on the x or y-axis, I go to the x-intercept, and this creates a vertical line. Anywhere I go along this vertical line, The x value is negative 6. So I have negative 6, 2, negative 6, 5, negative 6, negative 8. X's value is always negative 6. So this was a little bit of a trick question. What is the slope? There is no slope because it is a vertical line, so we call that undefined. What is the y-intercept? It never crosses the y-intercept or the y-axis, so there is none. Not 0, because 0 is a location. The answer is none. My slope for y equals negative 2/3 x plus 6 is negative 2/3, y-intercept of 6. So when I go to graph, I'm going to start at the y-axis at 6. It's a negative slope. We had a lot of students that missed the fact that it was negative. So I'm going to go down 2 units and to the right 3. If you go down 2 and backwards 3, that double negative action ends up creating a positive slope. We do not want a positive slope. We want a negative slope. So we can either go down 2 and back 3, or up, which is positive, and backwards 3, down 2 to the right 3. And that gives us our slope of negative 2/3, y-intercept of 6. Before we are able to graph number 9, we need to put it into slope-intercept form. Our slope-intercept form is y equals mx plus b. The goal in slope-intercept form is to completely isolate the variable of y. So I do this in 2 steps. I'm going to subtract 3x from both sides. So I have negative 4y is equal to negative 3x minus 16. Divide every single part by negative 4. I am left with y equals positive 3/4 x plus 4. Bunch of double negatives here. So that's my slope-intercept form. And then from there we graph just like we did before. So my slope is 3/4, y-intercept of 4. I start at 4. It is positive this time, so I go up 3 to the right 4. I can also go double negatives, down 3, backwards 4, and that will give me my line. Ten was very similar, and then 11 you had to explain it, so I'm not going to re-explain 11. How I am talking you through it is exactly how I would explain it to somebody else. So in order to graph this line, I need to get 2x plus y equals 10 into slope-intercept form. So I'm going to isolate once again to get y by itself. This one's a little bit nicer because I only have to subtract 2x from both sides. So I have y equals negative 2x plus 10. Y is completely isolated. I identify that my slope is negative 2. My y-intercept is 10. So I'm going to start on the y-axis at 10. And my slope is negative 2, which remember I can put over an imaginary 1 if that will help me with counting my boxes a little bit better. So I'm going down 2 units to the right 1, down to right 1, ensuring that this is a negative slope and that it is trending downhill. Finding the x and y intercepts. When we find the x-intercept, the y value is 0. When we find the y-intercept, the x value is 0. So I'm going to substitute 2 different times. So for the x-intercept, I'm going to substitute 0 in for y. 0 times anything is 0. So I'm left with 5x is equal to 30. And x is equal to 6. My x-intercept is 6. When I find the y-intercept, I'm plugging 0 in for x. 5 times 0 is 0. I'm left with negative 2y is equal to 30. Once I divide by negative 2, I get the y-intercept of negative 15. When graphing absolute value, we need to locate the vertex. So remember our general formula for graphing absolute value is listed, where h and k are our vertex. So within where my h value is located, I have 4, positive 4. So that means the opposite of h, or the opposite of 4, is negative 4. My k value is whatever the constant is. In this case, it is negative 5. So I'm going to start with plotting my vertex negative 4, negative 5. Then I'm going to use the a value, which is my movement. In this case, it is 2. So I'm going to rise 2, run 1, rise 2, run 1, rise 2, run 1. This needs to be reflected across the vertex. So I'm also going to rise 2, go back 1, rise 2, go back 1. And that gives me my absolute value function. 13 is similar. I need to locate my vertex. So we are the opposite of x, which is 2, and the same as y, which is 3. So my vertex is located at 2, 3. Then I look at my movement, negative 1/3. So down 1, right 3, down 1, right 3. This needs to be reflected across the vertex. So I'm going to go down 1, left 3. And there's my absolute value function. Linear transformation. So the first thing we needed to do is we needed to graph our original function, f of x equals 2x plus 2. So I'm going to start at the y-intercept of 2, go up 2 over 1, up 2 over 1, up 2 over 1. And that gives me my first graph. Everything is going to be a transformation off of my pink line, my original line. So my next graph, I'm going to take my pink line and I'm going to subtract 5. Well, it's outside of the parentheses, which means this is a vertical translation because it is affecting the y-intercept. So I'm going to move down 5 units. So I take each individual coordinates and I shift it down 1, 2, 3, 4, 5 units. 1, 2, 3, 4, 5 units. 1, 2, 3, 4, 5 units. And that gives me g of x. I do want to make sure that I'm labeling. This is g of x, f of x. All right, h of x is affecting the x value because it's subtracting directly to the x. So that means we are looking this time at a horizontal translation. And remember, it's the opposite. So since we're subtracting 7, that means we're going 7 units to the right. So I'm going to start at my pink line still, and I'm going to go 7 to the right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And that gives me my function, h of x. The last one's really the only one that you need to do any calculation with. We are looking at a vertical stretch, and we're also looking at a reflection because of the negative. So I'm going to multiply my original function, f of x, by -3. When I distribute that -3 through, it gives me j of x, which is -6x minus 6. So I'm going to start at -6, go up 6, backwards 1. Oops. And that gives me j of x. The final question, you were being asked to compare 4 different shirt companies. Buy More Shirts, Easy Calculation, Cool Shirts, T-Shirts R Us. The difficult part was that we had many different forms. We had the form of a table, so data in a table, data in a graph, data as wording, and data as a function or an equation. So it's hard to compare when they all look so differently. There were 2 main methods that were used, and the first was creating a table. An issue that some of us had when we created a table, though, is that we didn't include enough values. They wanted you to compare T-shirts from the interval of 20 to 200. Some of you didn't go up to 200 shirts. Some of you went up by 10s, 20, 30, 40, 50. All right, so I thought Buy More Shirts was a good example of if we were going to create a table of prices, it should emulate Buy More Shirts. So we should go in intervals of 20 all the way up to 200, since that's how many shirts they were looking at. So what I did is I just transferred my data over to table form. So with Easy Calculation shirts, 20 shirts was $100, 40 was $200, 60 was $300, 80 was $400, 100 was $500. I saw that the rate of change was increasing by 100, so I continued that pattern to finish my table. Cool Shirts was an initial fee of $125, and then every shirt was $275 per shirt. So its equation was represented by 2.75x plus 125. So when I created my table, I plugged in the values. So I plugged in $2.75 times 20 plus 125 to get out 180, 275 times 40 plus 125 to get out 235. I could continue that, or I could see, hey, this is a slope of 55 and write my remaining numbers. Same thing happened with Shirts R Us. It's written as a function, as an equation. So I plugged in my shirt value of 20, multiplied by 2, added 120 to get 220, plugged in 40 to get 260. Okay, I noticed that my change of rate was 40, so I increased by 40 each time. So part 1 wanted to know which company should you choose dependent on how many shirts you were going to buy. So Easy Calculation was our cheapest for 20 shirts. And then it changed right away. At 40 shirts, our cheapest value was either Buy More Shirts or Easy Calculation. They were both $200, which is the cheapest value. For 60 shirts, our cheapest value was still Buy More Shirts. And then from 80 shirts on, the cheapest price was Shirts R Us. So you needed to write that out in intervals. Who would you go to at what cost? So I would go to Easy Calculations for 20 to 40 shirts. I would go to buy more shirts for 40 to 60 shirts. I would go to Shirts R Us for 80 or more shirts. So that's what part A was looking for. Part B was, how many shirts should you buy for the best price? And what I did to figure this out is, I looked at the last set and the first set to see how much it cost per shirt. So $130 divided by 20, I am looking at $650 per shirt. Versus $760 divided by 200, I'm looking at $380 per shirt. Easy calculations, we're at $5 per shirt if I purchase 20. If I purchase 200, I have $5 per shirt again. So no change in value. At Cool Shirts, if I buy 20 shirts, I'm looking at $9 a shirt, versus if I buy 200 shirts, I'm looking at $338. And then finally for Shirts R Us, I have $11 per shirt if I buy 20 shirts, and for 200 shirts, I'm looking at $2.90. So my pitch would be, if we want to sell more shirts, we should be going to Shirts R Us because it costs $2.90 to make every single shirt. The second way that students were doing this was by graph. It's really easy to do this in Desmos if you were able to find each shirt company as an equation. So then you could compare the lowest shirt cost at the beginning. That was the blue, easy calculations. And then it changed. The lowest value was our red line, which is buy more shirts. And then it changed again at 80 for our cheapest value being T-Shirts R Us. So the graph was kind of neat because you could physically see the change between the different shirt companies.